We're going to look at another class of compound called esters. Okay, now esters are made by reacting a carboxylic acid with an alcohol, and you get an ester, and you also eliminate a molecule of water. So let's have a look at one. Let's draw. I'm going to draw butanoic acid, say. Okay, so there's the carboxylic acid functional group. Put the hydrogens on it. And we're going to react that with methanol. Now I'm going to draw methanol like this. I'm going to draw the alcohol group facing the carboxylic acid. Quite often you put it on the other side, but because it's going to react, so this alcohol group is going to react with that carboxylic acid group. So I've put the two together there. Now what happens is you break a bond here, and you break a bond there, and you eliminate this molecule of water. So you can see there's two hydrogens and an oxygen there, and the blue oxygen is going to form a new bond to the carbon in the carboxylic acid. So if I draw that, you have I'll draw it down below. The ester you're going to get is, it's going to look like this. So you've got 4 carbons from the butanoic acid. The double bond oxygen is still intact, and you're going to form the new bond between the blue oxygen from the alcohol to there. Okay, now that is an ester, and I just put the hydrogens on the carboxylic acid here. Now, I'm going to draw this in a slightly different way. Of course, we get water here as well. So I'll draw the water in the colours you get. So some of the water comes from the OH comes from the carboxylic acid, and that H comes from the alcohol. To save time and effort, instead of drawing it like that, the way you usually draw it is you will draw, instead of writing, so this group here, we're going to write that, call that CH3. So I'll write CH3, and that's bonded to this group here, which is CH2. Sorry. And then there is another CH2 next to that. And then we'll draw all of the bonds in this bit, because this is the important bit. Carbon-oxygen double bond. Another bond from the single bond to another oxygen. And then I will draw that bit of the alcohol. Draw that as CH3. So if we get used to drawing these bigger molecules with CH3s and CH2s, rather than drawing out every carbon and hydrogen, it saves a lot of time. Okay, so this is an ester, okay, and it has been made from, this is methanol, and this is butanoic acid. You don't actually have to know how to name esters for GCSE, but you need to be able to recognize from the name that it is an ester. And you'd actually call this particular ester is called methyl. That's come from the methanol butanoate. So the O8 bit comes from the oic acid, butanoic acid. So that's methyl butanoate. Right, I'll just draw another ester. Okay, so this time I'm going to draw, let's draw propanoic acid. So instead of drawing all the hydrogens on it, propanoic acid will look like this. You'll have CH3, carbon with 3 hydrogens, then a CH2, a carbon with 2 hydrogens, and then you'll have the carboxylic acid functional group, which you draw out in full. And let's have that reacting with ethanol. Now, normally I would draw ethanol like this. I'm drawing it backwards so that the alcohol group is near to the carboxylic acid group. So we normally draw it like that, but to save time, we're going to draw it like this. O, CH2, CH3. Okay, so that is ethanol. Now we're going to form an ester there. So once again, we're going to break this bond between the carbon and the oxygen, and we're going to break that bond there. And that is going to be taken out, and that's going to form water. So let's draw the product there. So we've got okay, so we're going to have CH3, CH2, double bond to the oxygen, and then that's going to be to the oxygen that was on the alcohol, CH2, CH3, that's from the ethanol bit, and we're going to get water there. Okay, so we've got our water, some of it coming from the carboxylic acid, the hydrogen from the alcohol. Okay, so what would we call that one? Well, we have got propanoic acid there. And we've got ethanol here. I'll do that in red. Let's keep the, that's ethanol. So if you look at the previous example, you can see that we call this the ethanol, but we call ethyl propanoate. Okay, so we look at the what is actually forming, what is the ester functional group, I suppose. Well, is the linkage sometimes causes linking two molecules together, is that bit there, carbon oxygen double bond, single bond into an oxygen, and there's the ester linkage in that particular one there. Okay, so that's esters. Now the thing about esters is that they, small esters like this, they smell fruity. Okay, and they are used as artificial flavorings in you know, yogurts and sweets and in shampoo and things like that to make it smell of apples, whatever. Esters also do occur naturally in fruits, and you know, you get a different mixture of esters, that what makes each fruit smell characteristic. Okay, so there's our esters. Now esters can actually form big, very long molecules called polyesters, where they join together. So let's have a look at how a polyester can form. Now if we just draw, I draw a carboxylic acid here. I'll draw it 4 carbons long. That can form an ester linkage with an alcohol, so I'll draw ethanol there. Right, now what can happen is, so they're going to form an ester linkage at that end, and you just form a small molecule. But if we change this end carbon here and put another carboxylic acid onto that, so and that would actually be called a dicarboxylic acid. So I'm going to rub that out, and this carbon now, there's a carboxylic acid on that end of the molecule as well. And if I go to this alcohol here, and instead of just having CH3 on the end there, if I put another alcohol functional group on that, so I'm going to call it CH2OH, we've got another alcohol group there. Now this alcohol and this carboxylic acid can also form ester linkages, and so the pattern can carry on. So I should put a bond in there. Right, so I'm going to show you what I mean by that. So if I draw another of these alcohol molecules here, so CH2, CH2OH, and it's got an alcohol on the other end of it as well. You can see here, well, that can form an ester linkage there, so you're going to lose that water molecule. And if I go over to the right hand side and I put another dicarboxylic acid here, you can see that that could form an ester at that end as well. Okay, and you can hopefully appreciate that could carry on forever, and you could form a very long molecule, which would be called a polymer. Okay, now polymers Poly means many. Polymers are made from joining very many small molecules called monomers together. In this case, the monomers, well, it's the black dicarboxylic acid and the blue alcohol or diol, because it's got two alcohol groups on it. So anyway, let's draw what that molecule is going to look like. So if I draw the ester there, and if we see each time you form an ester linkage, you're going to get a molecule of water being formed as well. So that this molecule is going to look like this, and then it's going to have that's come from the alcohol, CH2, CH2. That oxygen, the blue alcohols, blues come from the alcohol, and then we have the new carboxylic acid here. Okay, and I'll draw it as a free carboxylic acid on the end there. And let's go to this end where we get, and then we get the carboxylic acid group, but this one has formed another ester linkage to another ethanol molecule. And that's going to carry on. So I've drawn there, that's quite a big molecule, but you could appreciate that it could carry on forever. Now to save us drawing all that, what quite often you do is you just draw, it's called a repeating unit. So I'm going to put a square bracket there. So that's like the start of it, okay? And we're going to carry on. So this here is all come from the dicarboxylic acid. And then this here has all come from the diol, the alcohol with two OHs on the other end. And they can see I'm going to put another bracket there because what happens after that, this bit, is just simply a repetition of that. So the whole thing repeats itself. Okay, so what I've drawn between the two, the red brackets there, is called the repeating unit of the polyester. Of the polymer. Okay, and that could be, thousands long, multiply that by 1,000 times, you get a very, very long molecule, and that's called a polyester. And polyesters are used to make it's kind of a cotton substitute, so like shirts and jumpers and things like that can spun into fibers and make clothes out of it. Also plastic water bottles, they're also made out of a polyester as well, so it's a plastic basically. Okay, so just summarize what to make a polymer. So we start with polymer. Generally speaking, you start off with monomers, and you've got thousands of those. Okay, so and they're joined together to form one big molecule called a polymer. In the case of polyesters, the monomers are actually, well, it's the dicarboxylic acid, because it's got a carboxylic acid functional group at each end of the molecule, and it's the diols. So they are diols, they're basically alcohols with two groups on the end of it, two OHs on it. All right, and they are going to join together to form the polyester. And also you're going to get, every time you form one of those ester linkage, you're going to get some water formed as well. So these small molecules come together to form much larger molecules. Now polyesters are actually one kind of ester. They are called condensation polymers. And they're called condensation because you also, when you make the polymer, you also make, every time you make a link, you make a molecule of water. And if you see a later video, there are some kind of polymers which they're called addition polymers, and they're different. You don't make a small molecule of water every time they're made. Okay, so it is quite intimidating seeing these very large structures like this, but when you break it down, it's not as complicated as it looks.